Hey everyone, I'm trying to learn assembly language here. So what I have so far is the basic function here. I'm creating on the main function. Just say main. Let's see. Basically just main function, nothing on it. So when I run, when I debug it, this is what it says. This is it. That's what it is. We just NBR push to this RBP, ISP, move this to the other thing. Let me read up some documentation. Or we can just ask. x86 assembly basic information. Oh, okay. So somebody has this. Which one is the destination and source? I I think this is the destinations. Normally this is the destination. That's the source. I just say start. Ooh, okay. Start this. Yes, we'll debug it. You say, oh, you say step. Yep. So pop, P-O-P. Okay. x86 ASM. Which one is source and destination? So we need to know which one is source and which one is destinations. Oh, Wikipedia is pretty good too. Let's see, source. Okay. Oh, you say how to read x86 ASM code. There we go. Thanks, team. There we go. Which should be, that's AT&T syntax. I'm using Ubuntu. Maybe there's that one here. Which one is source? Which one is destinations? That's Ruby. Dartman. Dartman pretty good usually with the instructions here. There we go. So move is the instruction, move 4 bytes in memory at the address EBX into EAX. So this is the source and this is the destination. Okay. I say move. What if I say move RSP? Oh, special pointer. So I think this one is moving to this. That's a base pointer. So they have a list of register. Let's see, list of register, list of register, list of x86 instruction register, and explain. That's a flag. x86 register, EAX, EBX, EDX. I know they changed the letter depending on the implementations of it. There you go. Is this good information right there? Okay, architecture. So AX mean accumulator, BX mean base, so C mean counter. So this is in order: AX, BX, as it is. Where did I put it last time here? That's a list of it. So this is the unit of how many bytes per data type. Basically, assembly language has no knowledge of data type. We assign it to make us the programmer easier to understand. So yeah, this one instruction probably different. We have to say x86 assembly language here because we're using Ubuntu, we're using Linux, so this is Linux system. So let's see, introduction, architecture, CPU register. All right, CPU register. There we go. There's 1664 general register purposes, IAX. So there's an explanation here. What does it stand for? Abbreviation that will help us. This one I'm not gonna close that. So these are the registers on it. The 32 bits is this. This is the 64-bit register. Now starting with IAX. Since I'm using Linux 64-bit, so the register starting with R. I'm using CPU 32-bit, which is pretty old right now, standard. So that will be using EAX, which means accumulator register used in arithmetic operations. So we use that to add stuff additional. So in this one, we don't have any AX because we're not adding things. Are we? Probably adding memory here. Probably adding memory. Because you have to move memory here. AL. What is AL? Lowest bit. So we source, we trans destinations. All right, that doesn't give me anything. So let's ask questions in Linux. x86 assembly instruction, which is the source and destination for the register. All right. In assembly 86, general convention is the destination register is placed on the left, the destination on the left, and the source on the right. Is it really? In instruction, general convention is that the destination register is placed on the left. Destination on the left. That's pretty good. The destination's on the left. Move contents of register BX into AX. Okay. I guess in convention, that's pretty good. So in assembly, general conventions, because that operation is for in the destination register. Okay. Okay. Instruction is the destination and source. So basically instructions first, and then destinations, and then the source. That's how they're supposed to do it. So move IAX to AL register. What's to do? Okay. So this is the instructions for x86. Let's see there. What's the location on this? That's the memory main. Okay, we can continue. We're not gonna type that. So see, it's move ADI register. Continue. We'll push the R is the base pointer. Okay. So we're gonna ask, what is RBP in x86 assembly? Oh, there's a cheat sheet here. RBP. Okay. Pop and push is a procedural call. They are not necessarily safe across function call by convention IAX. They have to prepare your data or the place in memory, so it stores everything, all the instructions on there. So this is since RBP is a call E safe register, so RBP needs to be safe before you change it. So it puts the stack here. Therefore, the function prolog now to be prefixed with RBP. It's always going to be RBP in the beginning, and an RBP register will pass the data to RSP. This is the stack memory. RSP is a stack. So RSP is a stack used to point to the base of the stack. Basically, just this is how the function, how assembly code in x86 works. It will do that. But I guess it's not. I think we already went too far. We already stepped into too far. If we start, yeah, from the beginning. We'll just break it, I think. Yes, I'll just do this one more time. Main. So we say step. We'll lay out the ASM. I want to see that. You see that? This is the program here. So in the beginning, it always starts with the base pointer register used to point to the base of the stack right here. It has to. All right. And then it will move whatever on the stack, whatever on the base pointer register to the stack. You have to move it. So this is the opening of the program. Always push, have the register open here. The base pointer register is open. All right, and then move instruction there. And I know this one is return. Let's return. We have 0. Something here should be 0. But this, you see what subtracting this. What is 8? Subtract. So it's subtract RSP. Whatever on this pointer here, it's subtracting this. This is the break line. I think this is, what is CMB VR64. There we go. Terminate an indirect branch in 64-bit mode. This is AI. Give a lot of informations, which is good. Back in the days when you search all this stuff, you don't want to have all these informations. You can see RDX. Here, there you go. ENDBR64 and branch 64. Terminate indirect branch in 64-bit related to control flow enforcement technology. So it stopped. It terminates something. It terminates the one of the instructions. It returns. It subtract. They have to clear this from the memory, and then return back. So in the beginning, It's all the memory. They're all in the stack order, I believe. Calculator. X. Calculator. Let's see. 1129. No, I just need to know. 1129. 170. All right. 112D. 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 Hey, why it's not working here? 112D is 170. 1129 is 170. Okay, that's interesting. Okay, so decimal value is 1129. That's 170. That's weird. Clear, clear. 112E. 170. That shouldn't be. But 29. What is 29 in hexadecimal? That's just wrong. That is wrong. Calculator. That's not supposed to be. We would say 1129. Oh, hexadecimal here. 1129. That's the number. 112D. 4397. 4393. So it adds 16. 43. Okay. And I think it's adding where's my thing here? All right, we'll just write it down here. So 1129 is, oh, let's put 112D first. 2D is 4397. So when you put 1129, what's the address is 1129. I mean the conversion of the binary hexadecimal to decimal is 4393. It should calculate 16 because we get 4397 plus minus 43993. 4. So it's 4 byte different. So it changed 4 byte. Okay, let's see what the next one. 112E. Oh, change that. Forget. 112E. So 112E is 4398. It's easier if we do this. Oops, it's stuck. Oh, 112E is 4398. Conversion. Yep, program's not working. Okay. I'll continue on this pop min remove. Getting out pop min remove PLP x86. Oh, wait, let me say this here. PLP pop stack basically push the data out off of it in reverse order. Pop the element on top of the stack. Okay. So yeah, this is how to, I guess, to look up what's going on your programs. This is just basic. I will say start. Yes. I'll just put next. I think it's easier. Next. This program is not being. I think already exit. I guess the call already been done. All right. It's a simple program. Let's start one more time. Next. We're gonna pop it. I think almost done. Oops. I'm gonna say next. We move it to there. I think it's done. I think we exit it. You see here? Exit normally. Got it. Arguments. Yeah, it should be fine. Download fail. But so far it's good. So there's no error. There's no segment error because I think that's good. So this is the functions of main without anything on it. So simple program, but a lot of information on the assembly language because that's how program works. Basic program work that way. So it's left, and you can see a simple programming in C. It will take a lot of instructions inside the assembly language. All right.